Okay, so I'm going to present this project, the Decentralized Data Ecosystem for the Open Blockchain for Asset Disposition Alliance, a long name for an Open Call 2 project. The team combines people from UPC from Barcelona, Spain, together with Rohi Shukia from Obada, which is a foundation in the US, and also Ronald Lemke from the University of Nevada, Reno, also US. So we work together in a project that looked at the ICT products and climate change and how to enable the, sometimes people talked about the digital and sustainable transition, how to use digital technology to keep track of devices over the lifespan, of a circular lifespan, which includes use, reuse, repair, refurbishment, and final recycling. And then we use the attachment that we had from a previous project which is a permissioned distributed ledger or blockchain, was designed to experiment about device traceability and accountability. So the dashboard provides an Ethereum-like blockchain, but running on a cluster of nodes that uses it's called the proof of authority, which is a very lightweight consensus mechanism, which also can run code like smart contracts on the DLT machine, let's say. And then we had a prototype system in both sides, both in the US and in the European side, of a device inventory system that collects details about a bunch of computers or mobile devices we have. So it keeps track of them. It gives them unique identifiers, and then we can look at characteristics and analyze data and manage them to some extent. but you know, the problem of databases or data collections is that you never know if the current information is what was valid before, or how can you audit the information? How can you prove that a given device was bought 3 years ago, or that the data was wiped before selling the product in the second-hand market, which creates risks for the second-hand market, and you never know if the computer has been repaired or some parts have been changed, which you might imagine this problem in the market of second-hand cars, where people, they need to rely on the information they get about the previous life of a product. So we were looking at how to provide this verifiable registry, which allows you to have claims which can be validated, let's say, using DLT technology. So you can see in this diagram that we have a collection of devices owned by different organizations that get registered into inventory, and this inventory can send some proofs that, imagine like a public notary or an accountant that keeps a record in the DLT about events like I got this device, I bought this device with this invoice, I deleted the data with this proof, I repaired this computer, I used it for a certain amount of hours, and then that feeds an accounting book with information about this. And this is a networked service that Obada in the US was interested for a large group of second-hand companies working on refurbished computers, and we had similar experience in Europe, and plus the testbed from the previous NGI project. So what we did in this activity was that we did the experimental evaluation. So we, together with Obada and University of Reno, we defined a model and an API for running some limited experiments to assess the feasibility and the benefits of this DLT-based verifiable registry. And then, well, we did some experiments about measuring performance overhead of the system as the load of operations increased. And also we looked at the details about implementation of these APIs and so forth. And of course, we produced a publication, a scientific publication on this. You can see here a couple of graphs from the several measurements we did in the testbed, and you can see that, well, the more operations we have in a batch of recordings in the blockchain, the longer it takes, or the opposite is the transaction per second rate we get, well, fluctuates according to the experiment, according to the characteristics of the operations and the blocks that are recorded in the blockchain and so forth. So at the time when this project was run, it was a critical point because Ovada was defining their model, and sometimes you could hear concerns from industry people saying, well, is this going to be scalable? Is this going to work? So they could see that things work experimentally, and then it helped the process of developing this group of companies, a DLT system that still is in development, but already they managed to do some demonstrations. Also, some people in our group started to create a spin-off company to provide some of the services on top of the DLT. So these are the kind of things that happened during the project, and the testbed is still operational. We kept it. We expanded it. Last year because this project ended in August 21. So in 22 we got in touch with the European Blockchain Service Infrastructure. It's a pre-competitive contract to develop a blockchain service for public services in Europe. And we joined one of the groups in phase 2A, which was, again, laboratory testing, but they got selected for phase B, which is about to start next month. It's called phase 2B, where we are still bringing our tools to this new phase of the EPSI project. And we got involved into the broader concept of a digital product passport, but the product passport doesn't exist yet, and so it's a good timing. The work we did, the practical work with Ovada, they know the business, the work we did with the experimentation, with the joint collaboration, gave us a lot of early experience. And the result is that at the time when the project was running, there was interest in the ITUT, in the UN Agency for ICT Technology, and they got interested into this digitalization of product information. And we started a new work item in 21, which was about they call it the Global Digital Sustainable Product Passport. And we're still working on that. I'm co-rapporteur of Question 7 Study Group 5, and I'm the editor of the working group that develops we call it GDSPP, the acronym for the passport. And the digital product passport for ICT products or for other products, but mainly in ICT products, it's being developed at the moment. And the European Commission is in the process of sending a standardization request to Sensenelec and ETSI, and we are involved in that thanks to this kind of experimental introduction into the value of collecting information about devices over lifespan. And if you want to get details about the technicalities of the work, you can find information on the left on our website on the eReuse.org, which is an initiative involving several refurbishers in Europe, Argentina, and Kenya. And USD is the spin-off company that is being created at UPC to provide those services. Ovada is this industrial, mostly US, but also European federation of IT asset disposition companies, which are still expanding and developing their DLT-based offer, and we keep collaborating with them. And just to give you an example of one activity that kind of spin off of the project is that, well, this is one event organized by ETSI, the UN Environmental Program, and the International Telecommunications Union, where we discussed about DPP. I mean, there we didn't present the specific experimental results, but this wouldn't happen without this project. And in fact, you can also see the collaboration because if you look at the contributions to decentralization, with I mean, the European side mainly focused on ETSI and ITUT, which is based in Geneva, but the US part focused on ISO. ISO has created or approved a new work item on this topic, and then the proposal was led by the US side with NIST and supported, well, with OVADA supported by NIST, and we could participate into the discussion of the new work item, and our experience together was very useful to formalize better the work item proposal, and which has been successful, and sooner or later will start. So and I would have to add that particularly in this project, in addition to the timing and the results and the nice collaboration, I have to appreciate that it was probably one of the best projects in terms of supporting initiatives like this, because the overhead was very low, the meetings were very effective, the deliverables were extremely reusable for producing publications and other reports. So it was very efficient and effective. And well, thank you. That's if you have any comment, let me know.
Well, thank you very much, Leandro, excuse me. We appreciate the feedbacks, you know, on the deliverables and on the meetings. And, you know, as I said before, in the NGI family of projects, we try to keep the bureaucracy and admin, you know, to a minimum, but at the same time, you know, we have to, you know, to have a monitoring program. So, but we appreciate the comments, and congratulations on the good work, and the contributions to standards and interoperability are really tremendous, and your follow-up activities are great. So thank you very much for that.
Well, thank you also for running the project. It was really a pleasure.
Thank you. Jorge, do you want to say something?
I have a question, because of course this is a topic that is very much in the agenda every day, in particular with respect to blockchain. Out of curiosity, I have two questions. One is, when you compare blockchain, in particular, for example, EBSI, I understand they are not using proof of work, so the energy consumption will be lower. When you compare a blockchain, which is not proof of work, with other, I mean, IT is consuming a lot and also generating this problem of recycling, etc. I don't know, with YouTube or with other IT applications, is this much worse than the other ones, or is just the only one we point out? And then we are using all kinds of WhatsApp and with huge data centers behind which are in principle are producing, because the figures we are getting about IT are becoming quite high in terms of percentage of contribution to CO2 and also to other kind of problems. So how do you see this discussion?
Yeah, it's true that we cannot spend the savings from digitalization into the digital infrastructure. So that would be absurd. But there are efficient ways, and in fact, I mean, it depends on the problem. It depends on the restrictions. To make it simple, if you want to know which are the preferences of people, but you know how many people there are in the room, you can just count majority, and that's quite easy. But if you want to know which is the fastest runner, you need them to run, all of them, and only the winner gets the award, which is an absurd amount of energy you waste. So depends on the system. If you have a close group of participants, you can find efficient ways. which is, for instance, you can vote, you can collect stakes. You can find better ways than running and just choosing the winner. That's why we use permission blockchains, because in permission blockchains we know that we have 3 nodes or 5 nodes, so there is no tie, and if we can even choose turns, and then only one node in the blockchain computes the result, and all of the others follow. Or even if you are not interested in getting a strictly linear history, because there are 2 events which are concurrent, you can even create a mesh and say, well, I mean, I consider this operation successful as long as it is remembered by a couple of participants. Then you save a lot of resources. So I think that the blockchain or the DLTs have a bad reputation because there are very bad examples or very primitive examples that are nowadays being changed, because otherwise, yeah, I agree. As I said at the beginning, it wouldn't make sense to build an inefficient system to account for resources in which we save in one, we overspend in the other. So yeah, that is part of the EPSI2 phase evaluation, is to look at what is the performance that can be achieved, what is the overhead that we get, and find out solutions which are efficient and trustable and so forth.
And for example, in general, in terms of IT, because many times we are focusing on the use, on the energy or CO2 that is produced in terms of the use of the IT, but not so much in the production of the IT equipment and in the recycling of the IT equipment, which I believe also this has a quite important impact. So comparable, is it so much bigger the problem with the running of the systems than in terms of production and recycling, or?
Yeah, I mean, when you look at footprints, which is not just greenhouse emissions, but also depletion of natural resources and e-waste generation, the majority of the footprint takes place in the manufacturing part. So if we manage to produce less devices, that would be better. And that is a strong point for the circular economy. I mean, if you keep devices lasting as long as possible, we can reduce that cost and reduce also the impact on the raw material extraction, which also it's like means a lot of movement around the planet. So that's a strong point in favor of the circular economy and on keeping track of devices. But our current economy, I mean, our current ICT devices are far from being circular. I mean, the UN has a study on e-waste, and about 17% of all the computers or ICT devices that become e-waste in a year, 70% is recycled, 7% results in secondary raw materials, but then look at 83% of it is lost. So we don't know what happened. So we cannot call the ICT technology circular. We call it linear, aiming to be circular. And whatever effort that is done, for instance, to keep track of this information and to incentivize recycling, is going to reduce this 83% that we don't know what happens at the moment. So there's a lot to do. And I think the European Commission or EU initiative on the DPP is going to help significantly, because I mean, ICT devices are very expensive for the environment.
Thank you very much.
Thank you.